Okay, good evening, everyone. Thank you for joining in for this live session of Serverless Days Paris warm-up just before the event. Tonight we have Rob with us. Hey, Rob, how are you doing?
Hi, Frederic. Hi, everyone. I'm great, thanks. Thanks for having me.
Oh, yeah, that's a pleasure. Always a pleasure talking about serverless. We'll start in 1 minute or two. Just let some people actually joining in on the YouTube live stream.
Okay.
Let me see if everybody's starting to come over. Yes, starting to come in. Okay, so just before just before I leave the stage to Rob, I'll just do a quick sum up of what Serverless Day Paris and this specific 2021 edition is going to be. Let me share my screen to do that. Okay, so as you may already know, Serverless Days Paris 2020, the edition of last year, was cancelled due to COVID-19 reasons. And hopefully this year, we are making an in-person event, an in-person first-time event for the Serverless Days. The event itself will take place in Paris at Cité Universitaire in the 14th district. And it will take place on September 28th, so next week. We are expecting a lot of great content from various speakers all around the world. International speaker like Adrienne, Julian Wood, for example, Gareth, who's working in Serverless Incorporation, as well as local French serverless speaker who are making the community, the serverless community, an even stronger community in the tech landscape in France. I would like to take this occasion to thank our speaker, our sponsors as well, for Serverless Days Paris 2021 edition. Theodo, Cajou, Datadog, and Unify are partnering up with us in the organization of the event to make sure that it's a great event to be remembered. And now we'll continue with tonight's session program from Rob, who is going to share his views on the current way Lambda, the Lambda service from AWS, is going very generic, and he's going to share what should compute look like in the future for serverless computing. So, Rob, if you're up, I think I'll leave you the stage.
Super. Thank you, Frederic. Yeah. There we go. Lambda is dead. Long live serverless. Viva la serverless. What we're going to discuss can basically be covered in three categories. If you're a serverless builder today, you probably identify with the first. Lambda probably doesn't feel dead. So what do I mean when I say that? And then we're going to talk specifically about how you can use compute in general, the concept, as a competitive advantage, and how you can use compute to reduce risk, and how those are generally two approaches that companies take to employing resources generally and employing technology and compute specifically. And the goal for this is to have a discussion. So I will move pretty quickly through these slides. Please submit your questions as we go, and we'll discuss them during Q&A at the end. We can always come back to any slide or any point that you want to dive deeper into. I do want the focus for us to be around, digging into what probably is not a unanimously agreed topic today. So that's what we're going to cover. By way of an introduction, just a little bit about me and why you should care what I have to say about this. I'm the head of DA at Fauna, the data API for modern applications. Fauna is a serverless data store that allows you to read and write your data. So we are serverless. We support serverless building. I came to Fauna from the serverless team at AWS, where I was a developer advocate. So I'm, although this talk contains no confidential information, it is informed by my experiences there. And then I'm a previous SaaS startup co-founder, so I've built as well. I'm not just a product or a provider is not my only experience, but I have been a builder and had to consume and had to make technical decisions based on value to the business as well. And then I've had a host of other experiences. The point there is to show you the thinking across a variety of domains, small to large businesses, and even risk-based principles from time working at EY. The most important thing here is if you have any questions, just send me a DM on Twitter or send me an email. My Twitter handle and my email are both there on the slide for you, rob@fauna.com. If you're listening along and can't see the slides, I'm always happy to have a conversation. And in this talk, I've made some assumptions about you as well. If you find this talk not really resonating with you, then maybe I didn't quite understand who you are. I assume that you're familiar with what I'll jokingly here call legacy serverless computing, meaning functions as a service, most generally. I assume that you build software not just as a hobby, but to gain a competitive advantage for different definitions of build, right? Whether you're an architect or a developer or engineering manager. And that one of the ways that you do those are, like we talked about, moving faster than your competitors or reducing uncertainty and risk. And those are characteristics of companies at different life cycles. And I assume that you build for one of three common workloads, right? You take some set of JSON and you manipulate it into another set of JSON. You do operations on your data in place, like analytics or aggregation, or you manage your IT infrastructure, doing IT operations, backup restore, automated workflows, creation of environments and CI/CD environments. So I think my message will resonate with you if you see yourself on this slide. So I really wanted to use the Monty Python Holy Grail, I'm not dead yet GIF here instead, but I couldn't find an image light enough that would work on the slides. But Lambda is dead. This is crazy talk. And we do need to be honest by starting with some praise of Lambda, right? Lambda is foundational. It formed the basis of the serverless movement when it was released. And all of us, the audience for serverless days, serverless builders, really, it really resonated with us immediately and really fundamentally changed the way that we think about building software applications. So Lambda is foundational to how we build compute now. It was innovative when it was introduced. This, for all the haters who say it's just CGI BIM by a different name, it isn't. That's not what Lambda was. The concept of only incorporating your business logic and only running the pieces of code that need to be run was not how we were doing things at the time. And you can see this by looking at all the boilerplate involved when you go to do something like setting up a simple hello world application in the heavyweight frameworks that were popular when it was first introduced. And finally, it's a catalyst for growth. It's a very confusing picture there, but it's a catalyst for growth, not just for us and our applications and how we deliver them, but in the serverless space more generally. And that's in terms of competitors who introduce competing products. It's in terms of other services inside AWS that rely on AWS Lambda. It really didn't stop its impact with itself, but led to an entire generation of services and offerings from a number of companies that help us innovate. So we need to get those things right when we talk about Lambda. And Lambda is mature. And here's where we start to get to the double-edged sword aspects of it and the sort of the thesis of my claim here. When you look at sources like the Datadog 2021 State of Serverless Survey, almost, or you want to say almost everyone, but half fully of enterprises are using some sort of function as a service, and it's typically AWS Lambda. So it's not a competitive advantage for you anymore. Your competitors are out there building with Lambda as well. It doesn't distinguish your offering, and it's made it into pretty much every organization at any size. Now, again, this is a double-edged sword, and why I defined who you are up front, wanting to use compute as a competitive advantage, because the late majority and the laggards see this characteristic as a positive, right? It's a known entity now. There's tooling around it. It's stable. It's proven. There's Social proof, other companies have deployed it. So for the late majority and the laggards, it's now starting to become attractive for the very reason that we are now starting to look beyond it as innovative builders looking for a competitive advantage from our compute. And Lambda is a generalist service, as Frederic pointed out earlier. It's trying to be all things to all builders. Again, this is a function of where it is in its maturity life cycle. It's no longer just simple compute workloads. It- the configurability, and we'll look at this in a minute, that's required to make it broadly applicable means that it's no longer as effective when you have a specialized use case. And this, in the longer version of this talk, is where I talk about aviation history. Excuse me, I gotta sneeze. Pardon me. I didn't get to my microphone there. This is where we talk about aviation history and John Boyd, in particular, the creator of the OODA loop, who was tasked with creating a very specialized type of aircraft, a fighter jet. And by the end, by consensus, as it became more and more general, it became less and less effective at its actual role. And in fact, less effective at every role that was assigned for it. And this is a common pattern where a specialized tool gains popularity, gains adoption. And then to continue to appeal to a growing user base, it has to give up the things that made it attractive in the first case. And this is just a very specialized case of the innovator's dilemma. I apologize to my former colleagues at AWS, but Lambda is complicated now. It's, the other side of this is it's robust. It's this way on purpose, and that's as a feature, and it's this way to its credit. AWS is very responsive to the needs of customers, and when customers ask them for things, they build it. But again, that gets it into the place of this is only the configuration tab in the Lambda console now. And you see all the, I can't even count them. It's over 10 tabs down the left-hand side for various options. Again, each of those things is there because someone wants it, but it means the learning curve is so much higher. And most of those options you aren't going to need. So this is sort of why we want to get away from Lambda and look at more specialized use cases that we may have, or more risk-reducing use cases that we may have, where we can again turn serverless compute to be a competitive advantage. So let's take the first of those, compute as a competitive advantage. The first case I want to look at here is computing faster. And faster here doesn't mean the time to completion of your function. It means the time to completion of a round trip from the user's device, from request to response, right? And this is where the popular term today is the edge. You look at edge compute offerings, a number of vendors have them. AWS has them with CloudFront Functions and Lambda at edge. You have specialized vendors like Cloudflare with Workers or Fastly with their Fastly at edge compute option. And the goal of this type of compute is to render a more responsive and reactive experience to your customers. So it makes things feel faster. Lambda, by its nature, was designed to fit in a region. And everything running on AWS, with few exceptions, is defined to be in a region. If your customers are geographically distributed, then a single region doesn't offer that speed. Now, not all companies have customers who are geographically distributed. Not all applications need that speed. But if you either need the fastest possible response or you have users who are all over the world, then you need to think about bringing your compute closer to them. And for this, Lambda isn't the right solution today. You have next generation serverless offerings. Again, we talked about Cloudflare Workers is one that's shown here, that are going to be closer to your users at all times. And you have next generation data stores that aren't regional by design, like Fauna. That's, I think, the only mention I'll make of it in this presentation, that are also designed to be globally available. And they are designed thinking about a world first approach and then allowing you to scope down from there if you want, rather than starting with a regional approach and telling you that piecing together regions for a global solution is up to you and never really a good experience anyway. I lied. There's 2 slides on Fauna here. There's also client serverless, where you skip the function provider as well and run your functions straight in the database, which is a capability that Fauna offers you. That's another specialized use case of if you have multiple components that really only need access to data logic, to data whose business rules can be encapsulated in your database, then a globally distributed data store with store procedures or user-defined functions like Fauna, there are others, can be a good choice for you there as well too. Now, the other category of competitive advantage is for shipping faster. And in this case, maybe all of your users are geographically co-located, or you're only concerned with a particular region, or performance isn't the key characteristic or key competitive advantage that you have. There are other options today in serverless compute that allow you to ship faster, to deliver features faster with a more integrated experience. And almost all of these, certainly the 2 that I'm going to talk about today, actually run on top of AWS Lambda, but they run as another abstraction layer, or as at a layer above, where they make more sense to you as an application developer. So again, when we talk about Lambda being foundational and having a place in the future, I like to say Lambda is dead in the same way that EC2 is dead, right? It's, if I could invest in it individually and directly, I would. It's going to continue to make money for a long time to come, but it's not the easiest way to ship features. If you want to ship features more quickly today, you can look at platforms like Next.js that integrate their own serverless functions with an opinionated structure in the API folder, and a platform like Vercel, whose enterprise offerings allow you to publish your functions across multiple AWS regions. They have a CDN that they layer over the top of it that handles routing to the closest endpoint. And really, you're here in a single repo creating an application with all of its functions in place, sharing code as you need, but leaving the deployment, the orchestration, and these pieces up to the provider. In this case, Vercel, but there are others. This opinionated approach is still fully serverless. You're only paying for the invocations of your functions that you use. You're only paying for the data that's stored by your static site. It hits all of the characteristics of serverless, but it really offloads the interweaving and other sort of the serverless heavy lifting to the provider, and allows you simply to focus on writing the application and getting it out there. Another good example of this is the recent launch from the serverless framework of Serverless Cloud, where again, this is what one of your sample applications look like. It's very familiar to anyone who has written Express. You're just adding routes and adding compute. And again, although they deploy onto AWS and AWS Lambda, you don't know that. And you don't have to worry about that. They take care of the management, the orchestration, and even consolidating the monitoring for you. And when you think about, AWS commonly says only 5% of compute workloads are in the cloud, and not all of those are on serverless. There's a massive cohort of developers who will be coming to serverless as a concept in the near future over the next 5 years. Frameworks like this that meet them where they are give them a much greater opportunity to be successful sooner, and therefore productive sooner, and therefore shipping features that matter to your customers sooner. So that's compute as a competitive advantage. The other side of this that I mentioned was compute as risk reduction. You don't always deliver features that are new. Sometimes you don't want to deliver features at all. You just want to have things that work. And my personal favorite example of this is don't ship dependency updates. If you have the world's most robust CI/CD pipeline, but all it's doing is merging Dependabot issues to provide the same functionality to your users, that's not really a good use of anyone's time or the money that you're spending on it. You don't have to do that if you go through and leverage service integrations. And I'm going to give you a very AWS specific example here. But service integrations are when you allow your ingesting service like Kinesis to put information directly, or Kinesis Data Firehose, to put information directly into an S3 bucket without passing through a Lambda function. You have example of these from API Gateway to other services, Event Bridge, Step Functions integrates with a number of services. But the more that you can leverage these declarative service integrations, the more stable your code is over time and the less you're shipping. So you're not running CI/CD pipeline runs for dependency updates. Instead, the provider is updating the capabilities of these services underneath you, while your business rules and business logic that you've declared once stay the same until you decide to change them. So this returns that control to you. I did an example of this back when I was at AWS last year in 2020, called App 2025. And it's an entire event-driven architecture or event-driven application that uses the things we just talked about: Event Bridge, Step Functions, SQS, SNS, S3, Athena, Kinesis Data Firehose, to build entire workflows and entire applications that run on AWS. There was one Lambda function in there at the time because there wasn't a service integration from Step Functions to Event Bridge. They've published that service integration now, so you could actually do the entire solution without ever invoking a Lambda function, other than to populate sample data, right? But the core of the solution is free of Lambda functions, but still has all of your business logic in it. And this kind of solution is resilient. If you have back office processes that don't change or change, every 5 to 10 years, you put this up there and it just runs essentially forever. This again is the diagram from the repo that you see here on the slide. Events come into Event Bridge over time, and every business process that you have is modeled as a Step Functions workflow. For the transactional ones, it moves out to a data store. For the analytic ones, it moves through Kinesis Data Firehose into your S3 buckets for you to run analytics on using Athena. And again, we talked about the advantages of an architecture like this for workloads where you want stability are stability. There's no dependencies to patch. You don't have all these runs through. They're secure. You don't have dependency updates for security going on that you're responsible for. You're shifting the burden back to the cloud services provider under the shared responsibility model, putting that back on them so that if there is a vulnerability in a library consumed by one of the services, they'll have it patched before it's even public. So it gives you a more secure footprint. And these can actually be faster. When I built App 2025, I was really surprised at how performant it was. And when you stop and think about it, it makes sense because the services that are calling one another are able to couple a little more tightly, and you have an entire invocation of a Lambda function that is removed. So you have several stops in your call chain that aren't occurring anymore. So unsurprisingly, it gives you a little bit of a performance boost. So again, Lambda is dead in the sense that it's not what you should be reaching for as a builder directly, unless you're building products for other builders. We use Lambda internally. We use a number of other services, serverless services internally, but we also use EC2 internally. And I wouldn't recommend that application developers reach for EC2 either. If you're building applications that go straight to customers, you probably shouldn't be reaching to Lambda anymore. Instead, you can go global to reach a global customer base, or to the edge if you need a faster experience for your customers, or go to more modern frameworks that get you productive faster and allow you to ship more frequently, at least until you're getting started, and then eject as you run into other needs. And finally, you can use your service integrations for a stability advantage. If you're not looking for a competitive advantage for your code, but you're looking to reduce the amount of time that you spend just on operations and maintenance. So with there, I'd like to open it up for a conversation. I'd like to thank you all for listening to me. And again, if you're interested in Fauna, there's some links there for you to go learn. But you can also, again, find me on Twitch or on Twitter with the information here on the slides. And I'm happy to take your questions.
Thank you very much, Rob. It was a very interesting talk. Very debatable topic, that's for sure.
Yeah.
If I see a small stone thrown at you, I will understand why.
Yeah.
At the moment, I cannot see any questions from the community on our chat, but I did have a few of my own while watching your talk. You do refer a lot to AWS for your example, and I do understand that since you worked with them for a period of time. How would you say other competitor closer to AWS level in terms of complexity of services, something like Azure or Google Cloud, are doing in terms of the benefits and the disadvantage that you highlighted in your presentation?
Yeah. There's two key points that I want to pull out of that. One, if you're building, let's limit it specifically to Azure and GCP for a minute. If you're building specifically on Azure and GCP, they both have offerings for all of the services that we talked about in App 2025. So the general theoretical principle for reducing operations, if you're looking for stability, is there. There's Google Workflows. There's is it Azure Durable Functions, or I forget what the Azure Workflows product is called.
Yeah.
They both have their own event buses. They both have their own data ingestion, blob storage, and they're serverless solutions. So you can absolutely implement them there. Now the services have different characteristics, but the core is there. Their function offerings are I'm going to offend everybody equally. Their function offerings are behind Lambda, and that's not necessarily a disadvantage, right? Because their function offerings are accelerating and catching Lambda, and they have the core needs that you would want if you were actually still writing Lambda functions or writing functions as a service. In some cases, they may be less complex, meaning fewer features, but because they're less complex, they may be easier to build with. And if you're already into those ecosystems, then maybe that applies less for now. But I would still argue that the principle of you either want to gain an advantage, and so you want to move closer to your customers in terms of either speed of light or feature delivery, or you want to reduce operations. And then in that case, you want to return to the managed services. That one, the managed services, is much better for those major cloud providers. Getting closer to your customers, I think the newer generation of cloud providers, cloud service providers, the Cloudflares, the Fastly's, the Vercells and Netlify's, I think they have the advantage on that. And I think we're going to see them push to the edge more meaningfully, more quickly, with a better experience than you're going to see AWS do. That's wild speculation. That's what that's based on. But it's also based on my experience building with most of them lately.
Okay, that's a nice take on that. Regarding the last part you said, don't you think people are using those kind of abstraction on top of complicated cloud provider to ship faster to their user base at the beginning of an innovation? And as times pass and they want to go deeper into fine-tuning usage of resources around the world, they have to progressively ship to native cloud provider like AWS, Azure, and Google Cloud to have the level of complexity that is required by their preferred settings.
Yeah. So not in my head along as you went, and then you hit a part where no. I don't think it's inevitable that you need to object from the abstraction. I think you should be able to, but I think that's going to be on a case-by-case basis. You think about, there are small and medium enterprises that have their own in-house compute that may never get complicated enough to need or to merit jumping to AWS, that may be happier with the abstraction. Here, they're also not going to be building on Cloudflare Workers or Fastly because it's like one of my favorite problems to look at is in logistics, right? Like truck shipments and vehicle tracking and all of these things. Like, what do you load on which truck? Where do you send it? And they may have their own in-house solutions for that, but they don't really need to be at the edge. Like, it doesn't matter if the data comes back in 10 milliseconds or if it comes back in 1 second. And that's the sort of order of magnitude difference that you're looking at, right? And so in that case, the abstraction that allows them to deliver new features to drivers, packers, loaders, that is the more valuable one. And I have a hard time seeing them come off of it for something like AWS. Now, absolutely, the larger like enterprises may reach a point where it's a cost decision, but I think the abstractions or the other providers allow them to get to that point with data rather than trying to build from the beginning that way. That's just another premature optimization, right? If you think, well, when we get to scale, this is going to be expensive, so we're going to have to eject. So we're going to do it the hard way from the beginning. And it takes you 18 months to deliver a project that you could have delivered in 6 weeks. You burned all your engineering time on, and you laugh, but we've all seen it happen, right? And then worse, you get to 18 months, you ship it, and it has 50 users, right? And it never hits the kind of scale that you engineered for. You over-engineered from the beginning. Maybe the business rules changed, the company changed, maybe COVID-19 happened, right? So I would argue that the ejecting down to a lower level should always be a problem when it's a problem. But my preference, falling into sort of that customer definition that I gave early in the slides, is to compete based on shipping features, which is how I wind up in startups. So,
okay, nice. I see we have a few questions from the community, from Barney actually,
Hey, Barney.
saying that a lot of Lambda functions essentially just transform data. And what are your options when you want to transform data without relying on Lambda?
Yeah. VTL. Next question. No, I'm kidding.
Velocity. There you go.
VTL is an option. It's one of those things where unless you're at scale, I don't suggest you start there. Richard Boyd might disagree with me on this, being the master of VTL. But I would rather see you invoking a Lambda function that you don't need until you know the type of volume that you have to do that transformation, and then do it. Now, if you're doing this according to the model that we showed you in App 2025 on AWS, then your business process is a step functions workflow. Take the input that you get and use pass states to manipulate that by pulling objects or nested objects out of it, certain components, certain keys, rearranging them the way that you want, and then passing them into the next service integration. Anything that there's probably a theorem in there that I'm unaware of, but there's, you're talking about describing one shape of data into another shape of data. That's a declarative operation, and step functions can handle that, as long as it's always the same, right? And step functions is pretty robust. People might argue it's not an intuitive developer experience, and it certainly takes some learning. I think they've come a long way in the past couple of years with the innovations that they've introduced. The visual modeling, your ability to see the data flows that come in and out of states now in the console to help you out with that. Remember that the investment that you make in getting that transformation right pays off on long-running business processes that aren't likely to be modified, where you don't have to maintain that code over the long run. So I would look there. And then the classic, like 90% of compute is taking a JSON object and making it another JSON object. The classic option for that is the edge, right? Like, grab that request and mangle it before it comes into your infrastructure. And then if you're on AWS, that's CloudFront Functions. If you're not, that can be Cloudflare Workers. It can, you can do it a number of ways. But you have plenty of opportunities to reparse your JSON in less than a millisecond, in and out.
That's for sure. I think there is one last big blocker for this kind of architecture using declarative rather than programmatic execution of code, is developer, actually. A lot of developers are used to write code that is being run at runtime, and that it's very strange to shift from programmatically modifying a JSON to declaratively asking a service to modify the same JSON. You're not using the same tool chain, you're not in the same context, you are outside of your confidence zone, and it's much harder to give in those kind of services that make it better in the long run, like you said, rather than just writing code because I can.
Yeah, and this, I mean, that's why you see CDK being so much popular than CloudFormation and Pulumi overtaking Terraform for like third party, right? Because it fits the developer's mental model. I could talk about this for the rest of the time, so we have to be careful. But it's not wrong. I'm a big advocate of introduce one change at a time, right? So if you have developers who are used to declaratively doing things everywhere all the time, and then you put them in the cloud, they're already going to have new things to learn. So I'm sorry, I think I said declaratively. I meant imperatively. If you have, programmatically. If you have developers who are used to doing everything in Python or Bash, step 1, step 2, step 3, and you put them in the cloud, they have new things to learn. Don't also at the same time make them start thinking in an entirely new paradigm. This is similar to what you see when people approach functional programming, right? Why use functional programming? Well, because it's verifiably correct, and it's a much better way. Not when you're starting, it isn't. Like when you're starting, it's so hard to reason about. And declarative programming can be the same way. So I say all that just to say it's not wrong to use CDK, Pulumi, your own imperative or programmatic structures, but don't be satisfied there. Don't stop there. Like when you talk about declarative transformations from one set of JSON to another, don't just always do that by copying these things out, step 1, step 2, step 3. Once you're comfortable with everything else, and that's the one thing that you can change, go ahead and make that change and get comfortable there, because the benefit is that declarative syntax is also a function, right? The f of this JSON is this JSON, and you get the benefits of both with it once you're ready to break your brain and reassemble it that way.
Okay, it leads straight away to my next question. When you start configuring in a declarative way specific managed services from a cloud provider, don't you actually end up with an architecture that is completely locked in this current provider, while actually programmatically, imperatively declaring your transformation of JSON still gives you the option to migrate a bit easier from one to another?
In theory, the lock-in isn't going to be those services, because this is where we got your first question sort of hints at the solution to this. If you've worked out how to do a declarative workflow in AWS step functions using a number of steps in YAML, you got a couple of options there. Google Workflows also declares declarative workflows in YAML if you're moving to GCP. Apache Airflow, while traditionally used for data preparation, does allow you to sequence the same series of steps in Python. There's an AWS managed service for that, or you can run it yourself. So you have a number of options there. The real lock-in is your data. I won't beat this drum too loudly because it's a very fauna drum to beat. But the real lock-in really is your data. If you look at all the people that built on Kubernetes, like people that built what I'll call the wrong multi-cloud architectures where it's exactly the same everywhere, nobody ever does that migration. Nobody ever leaves. There are literally 0 examples of people doing that because it's just so much pain. So you're going to be locked in somewhere one way or another, right? And typically the data is the thing that has the most gravity. I think Ben Kehoe always says that IAM is the real lock-in. Identity and access management. Once you're bought into an IAM ecosystem, then that's much harder than taking a step functions workflow and rearranging it to a Google workflow that does the same things with the equivalent services there. So yes, lock-in is real. No, you can't get away from it. If you hide behind lock-in and apply effort to prevent it, then you're reducing the amount of effort you have to ship features to your customers. And your customers don't care if you can pick up and migrate from Azure to AWS or AWS to GCP or GCP to Cloudflare or whatever. They don't care. They're going to be much happier with you delivering a new feature for them that makes their life easier, that actually solves the problems that they have.
Yeah. This is where stands the value, not into which cloud provider you're actually using, of course.
Yeah. And not to make a contentious topic even more contentious, but ultimately cloud service providers are utilities. And there's going to be a race to commoditize them, right? I think the first cloud provider that realizes it's a utility for enterprises of the big three is going to win. They're going to be the one to be the most successful. That may seem just a wild claim because AWS has been out in front for so long. But the gap is closing, and I don't think, again, wild speculation here, but I haven't observed that they've internalized that they're a utility and started acting like a utility.
I don't see them coming with a phone number portability offer very soon. Something similar in the cloud ecosystem.
Yeah. It won't happen until they're forced to. And you can argue that Kubernetes is phone number portability, but it isn't. Portability and managed services. Managed services are a way for them to de-utility themselves to offer some sort of uniqueness. But then when each has the same managed service, you can see where it's going. And I thought if you've ever looked at the Google CDK, it's very different from the AWS CDK. The Google Cloud Development Kit is a series of abstractions over services. And it is, in a sense, the worst of multi-cloud as it tries to make an application lowest common denominator, right? You get blob storage. And if you want to do it across all three, you have only the common feature set to work with. You get compute, same type of things, right? But it's a really interesting abstraction that I think a third party could pick up and do better. Where why would you not run on whatever, if you weren't declaring your workflows as step functions workflows, but we're just declaring them as workflows, why wouldn't you run that just on the closest region? I don't think we're anywhere near that. That is a very hard problem. That's a very big abstraction, but it's not impossible. But I think the rise of the newer, lighter weight cloud providers is going to challenge whether that's even necessary or required.
Yeah, that's for sure. Before I hijack you again with another question, I see we have some more from Barney.
Barney!
What is the most common place you see function being used where they could be replaced with direct service integration?
Man, I hate to answer this question, Barney, but because we go back, I'm going to give you the true answer. Data. And this ties in with our conversation about lock-in and how you wind up somewhere, right? People that write Lambda functions that only write data to DynamoDB or retrieve data from DynamoDB, like that is a service integration. And my corollary for this, the general case then is third-party HTTP calls. Right? If all you want to do is form up a JSON body, some headers, and post it to an HTTP endpoint and get back some JSON that you know the shape of already, that shouldn't be a Lambda function. Now, this service integration doesn't exist. Arguably, it exists to a certain extent with EventBridge, right? You have HTTP destinations for EventBridge now where you can put them. But across all of the services, You don't have that. And that what that does is it makes it more difficult for third parties to integrate. And this is, I don't want to go too much into my beef here, but like a service integration like that would obviously be very valuable for Fauna, right? Middle of your step functions workflow, store your data in Fauna, or call a user-defined function, take the data that comes back and move on with your life, right? Because there are reasons that you would choose one data store over another. They're all trade-offs. Right now, if you would normally choose Fauna, but you're in this service integrated architecture, you're probably not going to, or you're going to have to do it through a Lambda function. So the specific case where I see the most that could be eliminated today are data storage and retrieval. The general case where I see them the most that I would like to see them eliminated is just all third-party service integrations.
And just to take a sneak peek at what Fauna is working on, are you actually planning on releasing like a CDK construct, actually allowing to include this step in a step function, doing this direct integration with Fauna? If you say this is where there is a game changer to help developer actually move from Lambda to direct integration, we could see a lot of third party actually building construct blocks for direct integration, for service integration in each of the cloud provider to ease up that step, rather than building a software development kit.
Yeah, and I think that has to be the approach, right? It has to be somewhat generic. This is painful for me, Frederic, because it's not the first time someone suggested that a CDK construct is actually the easy button or the easy way to get Fauna integration with an otherwise AWS native environment. There's definitely a hard way, which is get it in the CloudFormation registry, get it in the marketplace, all of these things. It's a lot of work. I mean, it's a lot. Like we've looked into it. I sat down one day and I said, okay, I'm just gonna knock this out. I'm gonna at least get to where I can call a user-defined function from or create one from within CloudFormation. And it was disheartening how much work it required. It feels like, I know it's not this way, so please don't come for me. It feels like they make it as hard as they possibly can to discourage third parties from doing it. Now, what's actually happening is AWS is a utility serving enterprise customers. They don't admit that, but AWS is a utility serving enterprise customers. Enterprise customers that would consume it have enterprise requirements, and the CloudFormation registry process reflects that. So just to get the level of comfort around it, they're imposing enterprise level interface requirements on it. That's what actually goes on there. Now, again, that's not the wrong decision for them to make. That's an understandable decision when you're a utility serving enterprise customers. But it means that pushing the work onto small companies like Fauna to do the integration without an easy integration toolkit, in practice means that it's just not going to happen. I would love to do it. If you have one, anybody that wants to write, anybody watching the stream 6 months in the future, whenever, if you want to write a CDK construct, send it over. We'll put it on Fauna Labs. I will send you swag. I will take you out to dinner when I'm in your town. Like, we'll work it out. I would love to have it, but it just hasn't risen up to what we can do internally yet. Yet is the emphasis that I want to pin on there.
I felt like CDK was really a way forward towards community to actually start building blocks, start building infrastructure blocks. And like you said, maybe not all third party have the time dedicated to building construct block for each service provider, for each utility, to integrate natively without running compute for those kind of tasks that don't need it. But maybe people in the community, in the open source community, will actually start building and see where it can go.
Yeah, that would be ideal. Because I mean, for us, we have trade-offs as well, right? Like, do we do that, or do we do a Terraform module that allows you to use Fauna no matter what cloud provider you're using, including no cloud provider? You can use Terraform on premise, call out to Fauna, and start doing augmentary workloads that way. So how do you prioritize those two when you're a very young, very small company? it's difficult, but if the community can kick in for it, then that's a great solution. There's history here too, right? The serverless application repository had tremendous potential, and next to no adoption, right? I mean, people have used it for hacks before layers, or no, they used it with layers, and then they started using it with other. Goiko Adzik has like a really nice hack that he always used it with. I can't remember it right now. I apologize, but a lot of clever stuff. But the idea that you would just like drop the line in your SAM template or in your cloud formation and it would just be there never really caught on. And I think, serverless framework did this with components as well, and it didn't really catch on. But that's interesting to me because all of these things should be really useful. I'm figuring it out as I'm saying it. I hate it, Frederick. Maybe the problem is us. Like maybe the problem is developers. We just want to make it ourselves.
We have a tendency to build.
Yeah.
Yeah, I see what you mean.
Push back against those abstractions when those things could have saved us a lot of time. So it's really interesting that they didn't take off. And then how do you make a bet with that set of data and then all the unknowns around which tool to make the bet on? That's tough.
Yeah, that's for sure. I don't think we'll solve this debate down there tonight, but no. That's a good way to start. I see we have another question, still from Barney. Thank you, Barney, for asking so much question. What are the differences between Lambda runtimes versus Cloudflare Workers versus Fauna functions?
Yeah. Oh, that's a great question. Let's start from Fauna functions. Fair. I work there. Fauna user-defined functions combine a set of verbs in FQL, the Fauna query language, and run on your data. Right there. On the same instance where your data is. Or at least the collection of instances, right? So what you don't have is a load everything out, copy it all over here, do some compute on my compute node, push back the results, write it back down, right? It can happen in the transaction pipeline even. So as you're doing the write, you can do the manipulation, the transformation. It's a really great place for capturing categorization rules, for data validation. You don't have to trust anything. And any business rule that you can encapsulate in a Fauna user-defined function can then be called from anywhere. It can be called from a client on an embedded device. It can be called from Google Cloud Functions, AWS Lambda, from on-prem, from any language, anything that you can get to Fauna with, you can then call that validation function. So it's right there on top of your data, but it's only right there on top of your data. Can it make an arbitrary HTTP call? No, it cannot. Can it invoke other services, copy data somewhere else? No, it cannot. And the reason we do this is because of it has to be deterministic. That's the premise of Fauna, right? It's how we do distributed data faster than everybody else and still correctly, is because everything has to be deterministic. Calvin paper, read the Calvin paper if you're interested in it. It's incredible. fauna.link/Calvin. It's out of Yale. It's foundational, but it's deep. So you can't have an HTTP call out because that's non-deterministic. You can have a network error. You can get a different response from the provider, et cetera. So only things that you have complete control over can be inside an FQL, Fauna query language, user-defined function. Lambda runtimes. Lambda runtimes are big. They're robust environments. You can have, I forget, what is it, 6 vCPUs now, 10 gigs of RAM. They can run for up to 15 minutes. Like they're sort of the opposite, right? They are not on your data. They're somewhere else. You have to give them everything that they need to compute. And they could do a lot of it, right? So you could get like massive scale out of these things. You can get massive like scale and long work, all of this stuff. You can get them in the officially supported runtimes, Go, .NET, Java, JavaScript, Python, Ruby. You could get them bring your own runtime. But they're big, heavyweight computing tasks. And that can include calling out somewhere and a retry and all of these things, although you should put your retries in step functions workflows. But so they're sort of the opposite, right? And then right here in the middle, you have edge compute function as a service platforms like Cloudflare Workers, the example Barney gave. You have Fastly at edge as well, a number of others. These are, well, I need to back up and say something about Lambda. Lambda runs on Firecracker, which is the isolation virtualization platform. So there's a lot of security guarantees that it gives while simultaneously giving you essentially a full computer or a full like conceptual computer to run in. All of the edge platforms that I'm aware of, and if I'm wrong on this, I apologize to the edge platform makers. I can't know the technical details of everything, but most of them use V8 isolates, which means they're using the V8 engine to provide separate compute areas, which are essentially, they're typically scoped down very small. I think originally Cloudflare Workers was 128 megabytes and like was it 1 millisecond or something crazy? Like very extremely limited on purpose, because the goal is, hey, here's a request, mangle it, send it on and be done with it. Now they're a little more robust than that. You can actually use it for routing. Cloudflare and Fauna integrate really well. The like single digit millisecond reads from anywhere around the world, caching, all of this stuff, right? Like you can do a lot more in it, but they're staying true to that. We're at the edge. We have to run light. We have to run very tight models. And one's not right and one's not wrong. It's just looking forward to the future. You're more likely to have problems that workers solve, or you probably already have them today. Whereas the solution to the problems that you're using Lambda to solve today, with some exceptions, are probably going to be in a service integration or somewhere else, right? Now, Lambda's not static. They're not going to sit there and never introduce features again or not introduce a new product like CloudFront Functions, right? So that's just sort of the state of where we are today and the bets that I suggest and would make myself when I'm building right now. So okay. Lambda, very big, strong isolation via Firecracker. Cloudflare, very small, very fast, very close to the user. Still good isolation via V8 isolates. And Fauna UDFs right there on top of your data can be done as a part of the read or the write in a strong transaction, but only in what's in Fauna. It's like a stored procedure. Stored procedures, hot again, everywhere. So hot right now.
I remember procedure, but not in a very good way at the time. So
I mean,
yeah, with Fauna, it's much better.
Yeah, and I used to write TSQL in Microsoft SQL Server 2000, and man. But now you can do unit tests on your UDFs. You can do integration tests. You can run Fauna local and just really beat them up. We talked about functional programming a little bit. You can do property-based testing on your UDFs. I mean, everything that's available to you in whatever ecosystem you write code in right now is available to you when you test your UDFs. So it's a different world for UDFs and store procedures right now.
It's a good thing that you have the testing tooling coming with it as well, because I remember earlier in the conversation, we were speaking about VTL as well. I do remember that testing VTL is not a straightforward task, and you are less confident in this kind of usage of specific managed services feature if you cannot integration test them to make sure it's doing what it's supposed to be doing.
Yeah. And I mean, we've got 1 minute left. I could talk absolutely for 2 hours on testing locally versus testing in the cloud with serverless, right? Yeah, VTL, I don't think there is a local option for testing. And I, of course, can be wrong. I'm not an expert in VTL. But the reality is, it's like when people would say, should I use step functions local? My answer is absolutely not. You should not use DynamoDB local. And today I'll tell you, you should not use Fauna local, Fauna dev. But the reality is, let's go back to that other bigger principle of only change one thing at a time. And for a lot of users, it does make sense to have those mostly sufficient copies running locally so that they can develop against them and even test against them before a final step of testing in the cloud. When you test in the cloud, if you're cost constrained, you don't want to discover anything new there. You want to confirm that what you have works, right? You want to discover new things at a low cost. And typically that does mean locally. So that's where a lot of those tools do have value, even though universally, everybody hates maintaining them. Everybody wishes you would rather just test against a real thing. But reality is you got to make one change at a time and get to that point, not start by ripping out everything and moving completely to a new paradigm, really.
It's funny you mentioned that because Gareth is going to actually talk at the Serverless Day event in a week time. He's having a subject about what should a development environment in serverless look like. Should be local, should be remote, to be completely exactly the same environment as your production. Should it be because it's much less costly now to actually host a complete serverless application on a cloud provider rather than before having to have a separate server to replicate the development environment? All those great questions. I hope you will have an answer to.
Yeah, I hope so. It's always a hot topic.
Yeah, another subject of debate, that's for sure.
Yeah, a lot of opinions there.
If I take something tonight with me from this talk, is really this thing that you said. This is very different in terms of paradigm, what serverless world is actually bringing to the developer landscape. And you should only do one change at a time to make sure you don't break everything. I really like the idea because I did see in a lot of migration project most of the time from not say old, but legacy infrastructure to more compute efficient architecture using serverless. And I see a lot of people not wanting to make this change because it does change a lot in the way they develop, test, ship, all this kind of stuff. And I think we're only going to see more stuff, more specialized services, more utilities emerging from this serverless computing world. And if we don't make a change at a time, we will be losing everybody for sure in the long run.
Yeah, it's just too much to manage all at once. You got to minimize that changing complexity.
Yeah. Great. That was really a nice evening sharing this thought with you, Rob. Thank you very much for your time and for your participation. Appreciate it a lot. Very interesting topics and very interesting key takeaway from this conversation. I think we have no more questions from our chat on YouTube, so we'll maybe call it a day. Thank you very much, everyone, for your participation and your time. Rob, if you want to have the last word of the day, it's your stage again.
Just want to say thank you. Thank you, everyone. Go out there, create features that create value for customers.
That's a great one. Thank you very much. And I hope to see you all next week for the Serverless Days on 28th of September. Tickets are still available on paris.serverlessdays.io. So please come and enjoy this whole day community event for all of you in Paris. Thank you very much. Thank you, Rob.